Now, if cycle 25 is similar to cycle 24, what does that mean for the higher HF bands? Well, this is the prediction from the Solar Cycle 25 prediction panel as part of NOAA, NASA, and all that stuff. On the left is cycle 24. The black curve is the monthly mean, 10.7 centimeter solar flux. You can see it's kind of spiky. And that's why we average the monthly mean numbers to get a smooth number. That's the purple curve. You can see it's smooth. It's very obvious that cycle 24 had two peaks. On the right in red is their prediction for cycle 25, and you can see it's pretty similar to cycle 24, at least in terms of magnitude. Will cycle 25 have two peaks? Well, I can get a coin out and flip it and I'll give you an answer, but we'll just leave it at that for now. Now, if we go back to slide 12 and that chart with what the solar flux values need to be to give consistent daily openings on the bands, that's what those green lines are. For example, if the solar flux is 90 for many weeks, then 15 meters should be open. So if cycle 25 comes out like the red line, then it says we'll have very consistent 15-meter propagation beginning in late 2022. 10 meters, well, it's going to take a little bit longer because it requires a higher solar flux value, which of course means a higher EUV value. 6 meters may happen. The prediction for cycle 25 from the Solar Cycle 25 prediction panel isn't as high as the EUV numbers in the chart and the SN sunspot number and the SFI numbers either. So you might think there won't be any 6-meter F2 propagation, but cycle 24 in its second peak had some good 6-meter F2 propagation. So it's very possible that we'll have some good F2 region 6-meter propagation in the fall and winter months around solar max. We'll have to wait and see what happens. Of course, if cycle 25 is bigger than 24, then the higher bands will come alive earlier and stay alive longer than the above data. Now, that's kind of disconcerting and discouraging and doesn't make you feel good because we still have a long way to go before 10 meters really opens up consistently. But the sun hiccups. And here's a great example. In the latter part of last year, the EUV, which is the green plot, spiked up tremendously. And what happened was CQ Worldwide Phone in October, CQ Worldwide CW contest in November, and the ARRL 10-meter contests were very good on the higher bands, on 15 and 10 meters. So every once in a while, the sun just hiccups, and it can give us very good propagation on the higher bands. Notice what happened at the beginning of 2021, though. Things kind of settled back down to solar minimum. But you can see that the green curve is a little bit higher than it was throughout 2020, especially before October. So it looks like the EUV and the sunspots and the 10.7 centimeter solar flux are showing a small increase, and hopefully it'll continue. This is a great look into the good things that are to come on the higher bands with cycle 25 when we get there. Now, another issue that kind of throws the general comments into array is very short-term events happen. We can't very well predict them. Here's an example in the 2018 California QSO party. There were no W6s heard on 10 meters in the Midwest on Saturday. And that's pretty obvious to see. That's the Boulder maximum usable frequency. It's only about 20 megahertz, a far cry from 28 megahertz. But on Sunday, there was a spike in the K index about a little bit after midday, UTC time. And Wonder of wonders. The MUF over the Boulder ionosonde increased to a little bit more than 30 megahertz. There were lots of W6s to work. So the Boulder ionosonde is in a great place. It's about halfway between W6 and the Midwest. So it was a great indicator of what happened here. So there's something you should do. If the K index spikes up, well, check the higher bands. You may be pleasantly surprised. So even though things are pretty bleak for consistent daily openings on the higher bands, short-term events happen that open them, and you got to be in the right place at the right time to catch it. Okay, some simple antennas for the higher HF bands. Lots of information in the ARRL antenna book. It's good to review what the tech and general privileges are on the higher bands. Well, technicians have CW privileges on 15 meters. There are still some novices out there. Interesting. No privileges on 12 and 10 meters. You have Ridian data and also sideband 28.3 to 28.5. So technicians are going to have a heck of a lot of fun when cycle 25 gets going. If you have your general license, that opens up things more. You get 12 meters and 15 meter phone, and you get the full 10 meter band on phone. Now, there's RM 11828, rulemaking number 11828 is at the FCC. It's been there for quite a while. It's called the Technician Class Enhancement. With COVID restrictions being relaxed, it appears that the FCC is going to act on several backlogged rulemakings in the third or fourth quarter, hopefully, when they get back to work. And this technician class enhancement will give techs 75 meter phone privileges, so 40 meter phone and 15 meter phone. So the best thing to do is get your general and don't wait on the FCC. That way you can take advantage of a lot of stuff. Okay, some antennas for 15 meters. Well, if you've been a ham for a while, you probably used your 40 meter dipole or your 40 meter inverted V on 15 meters. Works as a 3/2 wavelength antenna, has some gain in certain directions. One issue is if your 40 meter dipole or inverted V is cut for the middle of the 40 meter band, the lowest SWR in 15 will be up around 21.8, so above the band. So you'll probably have to use your tuner or an external tuner. I've used my Omni 7 with its internal tuner on 15 meters using my 40 meter inverted V, and it works quite well. If we had more sunspots, it would work a heck of a lot better. A vertical with 4 elevated radials works pretty good. I've used a Hustler 4BTV, and it gives decent results. Of course, you could just get really simple and just put up a 15 meter dipole or inverted V. The overall length is only about 22 feet. You get it up maybe 25, 30 feet, it'll do a very good job. Or if you're feeling your oats, you can get a 2-element Yagi. Driven element and a director. The element lengths are about 22 feet. It's on a 6-foot boom, so that's not real big, but it would give you gain in certain directions. And of course, that means you better get a rotator with it, probably. Complicates things. Antennas for 12, well, they're smaller. Each side of an inverted V or a dipole is only about 9¼ feet. 2-element Yagi's smaller than the 15 meter Yagi. And of course, the 3-element Yagi is not out of the question. It's still of reasonable size for small lots. 10 meters, well, just a dipole. It's only 16.5 feet or so tip to tip. And multi-element Yagis can be very reasonable. I have a 4-element Cushcraft 10 meter Yagi. It's a 16-foot boom. Elements are about 17 feet tip to tip. And I've used it to work many stations with my little homebrew QRP 10 meter transceiver. Of course, my little QRP transceiver is hoping that we have a really big cycle 25 because it needs sunspots, that's for sure. Now, if you want to have a 10-meter net for your local club work, a vertical is a good choice. A ground plane, which is a vertical wire with 4 radials on it. It's an omnidirectional pattern, which helps to cover, everywhere around the compass. A dipole would probably do okay. You'd have somewhat of a null off the ends, but maybe that wouldn't hurt too much if you're trying to work all your locals. And of course, it'd be best if everyone has the same polarization because it's line of sight, and there's a degradation of signal if you're one polarization and the other guy's the other polarization. But it can be done, and it can be fun. Okay, 6 meters. Well, they get even smaller. I have an MFJ 762. It's a 3-element 6-meter Yagi, 9-foot element, 6-foot boom, 3 pounds. There's a picture of it. There's its pattern. Of course, you definitely don't need a rotator for that thing. What do you do when 6 meter opens up on sporadic E to more than one direction? Like to the southeast and to the southwest and to the northeast. Well, you can use your rotator a lot. Or you could just about use any other antenna that has a reasonable SWR in 6 meters. Under these conditions, when the 6-meter Yagi was pointed one way, I used my 40-meter inverted V, and it worked people. So, take a look at your other antennas. Maybe you'll be pleasantly surprised. Okay, some specific topics that weren't addressed earlier that Ed brought up. One-way propagation. He started off his email by saying that he can hear EU on 17 meters in the morning, but it's tough to work them. I've had many experiences with one-way propagation. I've listed 3, trying to work K1TO down in Florida in the 10-meter contest. He had a pretty decent signal, but he just kept CQing in my face. It was really, yeah, what can you say? And then on 160 in the ARRL 160 contest last December, WD5OV in New Mexico. He had a great signal, and I couldn't work him. And he'd CQ in my face too. So, and then 75 meters in ARRL DX in March, J87XMO had a pretty decent signal. I couldn't work them. Many others couldn't work them. So here's some possible causes. Is there a difference in transmit power? More than likely, that's not the reason for Ed's experience and also my experiences. For example, a 1 kilowatt's only about 2 ES units greater than 100 watts. Now, maybe if the station you're listening to is running a kilowatt in your QRP, well, that certainly could be a reason. Difference in a local noise environment. If you're in a quiet rural location and the other guy's in a commercial or residential, maybe that's why he can't hear you. There could be a difference in receiver performance, but that's not too likely. I think most receivers are pretty similar nowadays. One thing that if a station's using a separate transmit and receive antennas, for example, he's transmitting on like an inverted L, which is pretty much omnidirectional, but he's listening on a receive antenna that's directional, he may not have the receive antenna at you. I don't think that was the case for WD5COV up on 160, that air reference. Something else was going on. QRM. For example, when a band is open within Europe, they can have lots of QRM over there from other EU stations, and they have trouble hearing North America. I see that on the contest reflector, on the top hat reflector, comments to that effect. The band just gets so crowded with strong signals, they can't hear North America. Now, again, I think that seems to be mostly on the lower bands and not on 17 meters. It shouldn't be, at least. One thing I have looked at previously is there a difference in required elevation angles? going one way versus going the other way, and doing quite a few ray traces. It doesn't show anything major, so I'm not sure what to say about that. And one issue that needs more investigation, I think, is polarization. So we'll talk about polarization here in a little bit. So I don't think I have a specific answer for any of these one-way things. It could be there's something else going on that we just aren't aware of yet. Gotta put our thinking caps on. Okay, 2,200 meters, 630 meters, and 60-meter propagation. Everything you wanted to know about propagation on these three bands is on this slide. Right? And if you believe that, there's a bridge near you guys that I have for sale, right? 2,200 meters down at 137 kilohertz. Well, the wave refracts from the lower D region and reflects from the ground. So because it doesn't get very high into the D region, it has minimal ionospheric absorption. Of course, the problems down there is you're only allowed 1 watt EIRP. Antenna efficiency is quite poor, and you may have man-made noise and atmospheric noise problems. It's a tough band, but amateurs tend to bring out the good in tough situations. Just like back in, I think it was 1912, when the FCC said, or whatever it was back then, that amateurs are restricted to 200 meters and higher frequencies. Everybody thought that was a wasteland up there. Well, we showed them, didn't we? Right. 630 meters, 472 kilohertz. Yeah, I think that propagation is somewhat similar to 160 meters. But again, it's got a 5 watt EIRP restriction, except for if you're close to Russia, in Alaska, it's 1 watt, I believe. Antenna efficiency is a heck of a lot better than 2,200 meters, but still it's a problem. And the man-made and atmospheric noise is a problem. Lots of good worldwide QSOs on 630. So again, hams show what can be done on a band. 60 meters, 5.3 megahertz. Of course, we're channelized there because we're secondary allocation, but that's okay. Usually there's enough ionization in the F2 region to refract 60 meters back to Earth, even at night. Thus, the important factor is the amount of ionospheric absorption. And that means the nighttime is the best. And DXQSOs are very possible, even at 100 watt limit on that band. W8GEX is a big 60 meter guy, and I see reports from him in Bernie W3OR is the daily DX every once in a while. Again, everything you wanted to know about those three bands is on that one slide. All right. Okay, the Earth's magnetic field. Well, the ionosphere is immersed in the Earth's magnetic field. And what happens is that makes the ionosphere birefringent. In other words, there are two indices of refraction that result in two characteristic waves propagating through the ionosphere. If the ionosphere wasn't in the Earth's magnetic field, there'd only be one wave that propagates through the ionosphere. They're called the ordinary wave, and it propagates as if the magnetic field isn't there. There's an extraordinary wave, which is dependent on the magnetic field. Its propagation characteristics are dependent on the magnetic field. So how does this affect propagation? Here's a very brief summary. On 75 meters and higher frequencies, the O wave and the X wave both propagate similarly. They're circularly polarized, but go in opposite directions. They pretty much follow the same path through the ionosphere to ground, and they pretty much incur the same amount of absorption. So that's, gives you two things. If the O wave isn't kind of working for some reason, the X wave may be. Now, when we get down to 160, the ordinary wave dominates due to the X wave incurring more absorption, and the O wave polarization tends towards vertical at mid to high latitudes. I can remember years ago when the OH8X station put up a 3-element 160 Yagi up in northern Switzerland. I can remember listening to their signal and comparing to another OH station that was using a four square, a vertically polarized, and the four square had a stronger signal than that 3-element Yagi. I think it had to do with uh, they really needed to put up a vertically polarized array to couple best into the ionosphere. But that's another story for another day. Okay, here's a summary. Cycle 24 is over. Cycle 25 is beginning its ascent. Most are forecasting a below average cycle. Let's wait and see what happens. There's an interesting website, prop.kc2g.com. It gives real-time worldwide maximum usable frequencies. He downloads ionoson data and adds in contour lines to give a worldwide picture of the maximum usable frequency. So you can look at that map and kind of take a good guess at what's going on. It's updated, I believe, every 15 minutes. That's when most of the ionosons update. DXmaps.com, you can see who is working what right now. There are similar sites, PSK Reporter, WhisperNet, Reverse Beacon Network, ARRL, NCDXF beacons. They all give a pretty real-time picture of what's going on. And all I can say is get ready for the higher bands as cycle 25 rises. Antennas are of a reasonable size for those bands, so start planning and maybe get something up. And I think you'll be very happy in a couple of years, and every once in a while when the sun hiccups too, or the K index spikes up. All I can say is get radioactive on HF. You'll have lots of fun. Ed, that's all I have.
Perfect, Carl. Thank you very, very much for a really great presentation. So we've got some time. So who has some questions?
Carl, I've got a question for you. What other long-term cycles, Earth-wise, are going to affect propagation?
Okay, that's a good question, John. One thing that we have to realize, and it's not real well known, is that the atmosphere changes throughout the seasons over a year time frame. In the northern hemisphere, the fall and winter months are best and result in the highest maximum usable frequencies. Now, it so happens in the northern hemisphere, that's where the three major ham radio populations are: Japan, North America, and Europe. And think to CQ Worldwide contests, October, November. So that's one pattern, one Earth pattern that helps a lot. You know, as cycle 25 rises, we're also going to get a little bit of a boost in the fall and winter months coming up. So things, I think, will be quite a bit better this fall and winter for two reasons. Because the ionosphere is better in the fall and winter, and cycle 25 hopefully will have risen quite a bit farther. Let's see, any other Earth time things? Well, yeah, the months, the equinoxes have the months with the highest elevated K indices. So that disturbs propagation the most in the equinox months. At the moment, I can't think of anything else, but I'm sure I will later, or in the middle of the night, and I'll wake up.
The reason I asked that, Carl, is I teach occasionally environmental science. And of course, we talk about the year without a summer when Tambora blows up and you've got all that crap floating around the atmosphere, and you had snow in Boston in July. So events like that, I'm sure, affect atmospheric ionization.
Yeah. And that kind of ties into what I mentioned earlier, the events in the lower atmosphere coupling up to the ionosphere. We don't have a real good handle on all of that yet, but hopefully we will someday. You know, hurricanes, you know, there's a hurricane season, right? I think it's June through November or something like that. Well, hurricanes, I'm sure, can couple up, and they can send an atmospheric gravity wave up to the ionosphere and screw it up, or at least make it vary like we don't expect it to vary.
Actually, that's a really good question, John. There is a group on Groups.io, and Carl, I don't know, just in terms of discussion on it. I just saw it the other day. This is at WX2R. in terms of looking at earthquakes and the effects on propagation.
Yes.
That's the first time I had ever seen anything on it, and they report every day. So
Yeah, we can see the signature of an earthquake in the ionosphere, but all the data I've seen so far, it's very minor, and I just don't see how it can affect propagation. So
That's a good point, Ed. There's a wonderful book. It's an oddball, nerdy book, How Apollo Flew to the Moon. Well, they had real problems with their radar because they were looking at what were called then mass cons on the moon, differential gravity points. And
yeah,
it screwed up their calculations, and it caused some of the LEMs to have to rethink where they were going to land. So, I mean, there is an effect with gravitational waves.
there's a lot we don't know. I think it's a good way to summarize it.
yeah. Other questions? I think one of the other questions we had, Carl, was on medium wave.
Ed, excuse me, we have a hand raised.
Oh, sorry, Jim, N2JLF. Sorry, I didn't see you there, Jim.
I heard something the other day called a Carrington effect. I think that affected radio and a lot of electronics back in the day. Are you familiar with that? And how would that affect the atmosphere?
It'd be a mess if something like that happened. It was a big, I think it was a real big solar flare, an X class, and also a coronal mass ejection. It's Carrington because that's the guy who noticed it. Just think if I would have noticed it, it would have been a Luetzelschwab event, right? Right. Okay. But yeah, it's if something like that happened today, we'd really have problems with our satellites and our communications and everything. And more than likely, it's going to happen one day. Yep.
I have a question.
Al, K2AL. How are you?
Yeah, hi, Ed. Ed, how are you?
Good.
Yeah, very good, Carl. I have a question. Are there enhanced conditions? I seem to know around the vernal equinox, and what causes that? Is it just increased daylight, or are there not increased enhanced conditions? I always thought it seemed to be better around the spring, or there seem to be improved conditions.
Yeah. Well, there's like the vernal equinox. That's when the northern polar cap starts getting more sunlight, and that increases the maximum usable frequencies, and that's when we get to start working Russia and all that over the pole. So that's one thing. Remember, the equinoxes are when the K indices are mostly elevated. So there's a not too good. And the other thing I've read about is it makes the ionosphere in both hemispheres more equal, and that could help too. Al. But other than that, I'm not sure I'm aware of any major effect.
Okay.
There's a lot of things that happen, and you have to kind of look at all of them and see how they fit together.
Other questions? Okay. So
K1UH, Greg here.
yes, go ahead, Greg.
Does any of the solar activity affect polarization? In other words, I understand that once a wave refracts twice, the polarization changes. Does the solar have any impact on polarization?
Like a coronal mass ejection can screw up the F2 region. It changes the F2 region, so you would expect that a wave will do something different than if it was a quiet time. So yeah, and also at solar maximum, there's going to be more refraction, and that's why the higher bands are open, because there's more refraction. So yes, solar cycle does affect refraction. Does it affect polarization? Probably, because polarization is dependent on electron density and what the magnetic field is doing too. So I'm sure there's a correlation there.
Thanks.
Other questions? Okay, no more. I think,
I have a comment.
yes, go ahead. Is that Bob?
Yeah, this is Bob
W2XS.
W2XS, right. It's about the polarization.
Mhm.
I'm a former physics instructor. I know I learned a little bit about the ionosphere, polarization, etc. I think there's always a polarization change. There's almost always a polarization change upon reflection. In other words, you can't be sure you're going to have horizontal polarization or vertical polarization or what. You may be transmitting one polarization, but the polarization is definitely going to be obscured or changed upon reflection.
Yeah, the polarization as a signal goes to as a electromagnetic wave goes to the ionosphere, its polarization is changing all the time. It's up in the ionosphere because it depends on the direction of the wave with respect to the magnetic field. It depends on the magnitude of the magnetic field. So yeah, it's what's really important is what's called the limiting polarization. What is it when the wave enters the ionosphere? Because that's the polarization you should use to couple the most energy from your antenna into the ionosphere. And when it comes out, you should know what that polarization is coming out of the ionosphere so you can couple the most energy into your antenna. It may require vertical or horizontal or something in between. But our linear polarizations tend to work pretty good most of the time.
Anything else from you, Bob? Okay,
I was just saying, we have no way of knowing how the polarization is changing as the wave is reflected.
No, not really.
Okay, we agree, Carl.
Yep. Yep.
thank you, Bob. So any other questions? Okay, because we've got one item of business yet to complete. So, and that was, for those of you who checked in early, okay, is that we do have a copy of Carl's book, the CQ Shortwave Propagation Handbook, that we're going to give away tonight, courtesy of Rich Moseson, the editor of CQ Magazine, W2VU, who's graciously donated a CD of the book. So when you entered the room, for those who may have been late, okay, I set up a random number table, okay, so that you didn't have any position bias in terms of when you came in. So, but we had 41 people in the room at 8 o'clock, which we sort of set as the time. And so from here, Carl, I'm going to ask you, okay, since we're really scientific and we've got one to give away, if you can pick a number between 1 and 41, and that's our winner tonight.
Okay, 17.
17, WA2BAU. We have a winner.
Wow, thank you.
Gary, WA2BAU, okay? And I will tell Rich to drop the copy, and your license address is good, I assume, yes?
Yes, it is. Good.
Yes, it is.
Also.
There we go. So perfect. Congratulations to you. And thank Rich, and I'll thank him on your behalf. So anyway, any other questions for Carl before we go? Carl, thank you very much on behalf of Fairlawn for a great presentation. So I see a lot of hands. I've seen some notes come up on the screen. Okay, and obviously good DX to everyone. Okay, hopefully what you learned tonight, okay, we can translate into good scores. Okay, particularly for field day going forward. So
yeah, thank you.
The last word.
Thank you for everyone for showing up, and thank you for the comments in the chat room too. And
perfect. Okay,
I'm going to leave.
Thank you, Carl.